Hello friends, today we are going to see the distribution models which are there in NoSQL. Now actually you know that the primary aim of NoSQL is its ability to run a database on a large cluster. Now if the database volume goes on increasing, then we need to scale out. So one of the solution in NoSQL databases is scale out. Now scale out means what? Run a database on a cluster of servers. Okay. Now depending upon your distribution model, you can get a data store that will give you the ability to handle some large quantities of data. Now your DBMS can able to handle only small amount of a data or some amount of a data, whereas your NoSQL databases can able to handle petabytes and terabytes of the data. So if you want to handle the petabytes and terabytes of the data, then the data distribution will be divided into various parts. Now this data distribution is divided into two parts, replication and sharding. Now what do you mean by replication? It takes some data and copies it on multiple nodes, and this replication can be further subdivided into master slave and peer-to-peer replication. And in sharding, now what do you mean by sharding? Sharding puts different data on different nodes. Now let us see something about the master slave replication. Now before we start with the master slave replication, we are more interested in finding out what do you mean by a single server. Now in a single server, there is no any kind of a distribution. So there is a database which runs on a single machine, or a single machine handles all the database, and it allows the people to manage the data. Now we have done with the graph databases. This graph databases works best in a single server configuration. Now we'll see what do you mean by master slave replication. Now master slave replication, for this the diagram is this is the diagram for master slave replication. Now what do you mean by master slave replication? It contains one master who is responsible for handling your data and who is responsible for read and writes, and it replicates the data across the multiple nodes. So you can see here the master is there who is replicating the data to these slaves. So these two will be treated as the slaves which are responsible for only read request, but this master is responsible for the read and write request. So it is nothing but, the master is nothing but the authoritative source for the data and is responsible for processing any updates to that data. And other nodes we can call it as slaves or secondaries. Okay, so you can see here the master which will take into consideration the data, and all updates should be made at the master level, and whatever will be the read request, those read requests will be propagated to the slaves. So these are called as slaves. Slaves will handle read request. Okay, so it is very much helpful for scaling whenever we have some read intensive data sets. Slaves, they sends the read request which is been handled by the master, and read resilience is also there. What do you mean by read resilience? If master server fails, then slaves will handle the read request, and it is useful if your data access is read only. Okay, so even though the new master fails, new master will be appointed and the rights affects. If slaves are replicated, then the slave may become master. Many of the times it may possible that your slave may become master in that. Then this particular masters can be appointed manually or automatically. Now manual means what? We have to configure our cluster. You can configure one node and you can designate it as a master. And automatic means what? You can create a cluster of nodes and you can elect any one of the slave to be a master. So this is all about the master slave replication. In the next session, we'll see something about peer-to-peer replication. Thank you.